My name is Ilya Grigorik. I work on the developer relations team at Google, where I focus on all things web performance, on projects like Make the Web Fast, which we have at Google that does exactly what it says it does, and Chrome and other related things. But here in this talk, I'm actually not talking about anything Chrome or even Google specific. Instead, I'm going to focus on a lot of the things that we've been working on in the W3C Web Performance Working Group, and tell you about some of the things that are already there, but despite being there, are perhaps not being used as widely that they should be, and also some of the things that we are thinking about in terms of adding new capabilities to the browser, and are looking for feedback, frankly, from you guys as well. So if there's actually one takeaway, I know that the standards process can seem like a big beast, and it'll consume all your time and all those things. It's actually not true. I do encourage you guys to sign up for if you care about web performance, definitely do sign up for the public web performance mailing list. There's nothing that you need to do or like sign away to do that. You can join in and listen and also participate in discussions. And do we have a question?
Can you speak louder, please?
Okay, I'll try to speak louder. Okay. So some of the actual specs that are already there and some of the things that we're working on. So it's actually a pretty long list, and I don't have the time to go through each and every one in this talk, but we will talk through a bunch. So there are things like fundamental components for things like performance timeline, which is where all the data lives. There's things like animation timing, which is or more commonly known as request animation frame, which is what enables us to do much more efficient animations on the web today, and a whole bunch of other stuff. So I'll spend roughly half and half of this presentation talking about the existing stuff and some of the upcoming stuff as well. So with that, let's actually dive right in. So this is probably something that you are familiar with, and if you're not, you should definitely read the specs. There's lots of great tutorials and hands-on guides for how to use this. So navigation and resource timing are two APIs that provide low-level timing metrics into how the page was loaded. So for example, if in your browser you query window.performance.timing, you will actually get a JSON object back with a lot of different timestamps that will tell you things like how long did the DNS lookup take, how long did it take to connect to the server, how long did it take to fetch the file, and so on and so on. And then you can actually repeat the same process for each and every resource that is being used by the page as well. So we need dozens, if not hundreds, of resources to compose a page, which includes CSS, JavaScript, images, and all the rest. You can actually figure out if your, for example, CDN is working as it intended. Is it delivering the resources in a timely manner, and all the rest. So in practice, this can be a little bit unwieldy. If you've ever worked with navigation timing, you'll find that there's like 20 different timestamps, and you're not quite sure how to line up all of them. Some of the tips, or a good technique, is actually to go read the spec. There's a diagram there that visualizes where each mark starts and ends. So that's very helpful. And another useful thing is actually timing.js, which is a library that's been put together by Adi Osmani. You can find it on GitHub, and it's effectively just a helper library that wraps a lot of the low-level metrics into more accessible metrics, like things like how long did the DNS take. If you wanted to get that answer with navigation timing, you would have to subtract 2 timestamps. This just makes it easier, and also it provides some helper methods for simple things like print the table. So in your console, you just type that in, and you get a nice summary chart, regardless of if you're using Chrome, IE, or Firefox. Just a little summary of what's going on. So a nice thing to have in your toolkit. The cool thing about navigation and resource timing is effectively, just like the waterfall that you see in your developer tools, you can construct it with JavaScript, which can be, if you think about it, quite a bit of data. So it's useful, but you should think about where you want to use it. For example, let's say you have a very slow page load for a particular user. You could actually have conditional logic that triggers for that particular user that says, okay, fine, something really bad happened on this page load. Let me trigger this logic to construct this waterfall and send it back, beacon it back to my server, such that I have a log of this particularly bad load sequence. And then you can analyze it and figure out, maybe it's a particular resource that was held up, maybe there was a networking problem, or maybe it's something in your code that you've deployed. And maybe it's a particular problem on that particular client. And this is perhaps one of the most important things about navigation and resource timing, is unlike testing in your own developer tools, this is coming from the user's device, right? So you're testing on your development machine, the user's running or accessing your site on their particular mobile phone, which may be an older device, it may be in a slower network. So you're getting this data from real users in real network conditions, which is incredibly useful. And this actually brings me to some of the performance best practices, which is you really should have 3 things in your development cycle. The first one is having a performance budget. So things like every time you check in your code, you have some automated build that is already running some of your unit tests and regression tests and all the rest. And somewhere in there should be a performance budget that says all pages, even while you're in this particular environment, in your build environment, should fulfill these criteria. Like they should load within a second, or you should have no more than 2 megabytes of images, or the CSS should be minimized. Those kinds of linters and checks can do wonders for just catching errors before they're shipped to the users. Second one is synthetic performance testing, which is it's more of an operational thing, where you may have a service or a third-party service or a bunch of points around the world that you test your site to see how well is it performing. So you have, perhaps you have a check running from London, from Tokyo, and from San Francisco, and you're just testing to make sure that your site is accessible from everywhere around the world. It's just kind of the rudimentary basics. And then the last one, this is the one that is enabled by navigation and resource timing, is real user measurement, which is how did the users actually perceive this page load? How did it actually work on their devices? And here you can actually find a bunch of vendors. If you don't want to build your own kind of analytics backend to aggregate this data, you'll find lots of vendors already collecting this data. So Google Analytics, Sosta, New Relic, they all have integrations which are able to collect this data and give you low-level insights. And you really need all 3 to have a good performance strategy. So all of those things exist. Some of the new things that have been just added to the spec, they're not available yet in any browser, but this is now in the spec. One of the use cases that we've heard a lot from you guys on the mailing list is figuring out, now that we have more than one protocol, if I'm deploying Speedy, if I'm deploying HTTP2 or something else, which protocol is being used? Is my CDN actually enabling those things? Because we've seen cases where you think you have it, but you actually don't because of some misconfiguration either on the server or on the proxy or somewhere else. So now you can actually query that on the navigation and in each resource. Simple, seems like it should have been there all along, but it took us a bit of time. The other one is perhaps more useful from just a kind of day-to-day performance, is the actual size of the resource. So while we told you the time that it took, we never told you what was the size of the thing that you fetched. And there's actually 3 different variables that are being exposed. And it may seem a little complicated at first, but trust me, it makes sense. So transfer size is the actual thing that was transferred on the wire, plus the overhead of the protocol itself, so things like HTTP headers and other stuff. Encoded body size is just the payload that you transferred. So for example, if you're transferring a CSS file, it's just the CSS file, and it's the compressed size. If you applied compression, that's how much it took. And then after decompression, what was it? So the cool thing about this is you can actually now figure out questions like, how much overhead do I have? If I have super large cookies in kilobytes, you can actually detect that. If you're not applying compression, you can actually detect that as well by comparing these 2 variables. And this sounds kind of silly, but it's actually very important because we've seen cases where the origin server or your servers are assuming that your CDN will enable compression, but then they forget to enable some flag, and before you know it, you can detect it. So with this sort of thing in the browser, you can actually detect that automatically and beacon it to your servers, and just it's much better all around. So these are 2 new things that are just landed in the specs, and I'm hoping we'll get the browsers to pick them up soon, and they'll be available in 2015. So that will help you optimize page load time, but speaking of page load time, this is one metric that we definitely, as a community, need to move away from. And this diagram, this is actually from a blog post by Pat Meenan, who runs Web Page Test, is a great illustration of why page load time is a very misleading metric. So page load time means the spinner has stopped spinning in the browser. We've fetched all the resources, we've rendered all the things, there's nothing else going on the page. And that's what we measure today by default. But that's not particularly useful because if you look at this film strip at the top, you probably can't make out the details, but that's not the point. The point is that much earlier on, about half a second into this entire sequence, the content of the page was already visible up here. And in fact, all the relevant content to the user was already visible. So the user was able to start interacting with the page about half a second in. But then there's other stuff being loaded in the background, and after 3 seconds, we finally say, we're done with the page, right? So I think we can make a strong argument that a relevant metric here is actually at 0.5 seconds, right, at half a second. That's what you should be measuring. But conversely, let's look at this page load where we've loaded the Chrome of the page, like the actual layout and all the rest, but the content that the user actually cares about, in this case it's a couple of pie charts, comes in way at the end, right? So you can't make a general statement for things like, oh, if you rendered the header, it's done. The real insight here is it's really up to your application to figure out what is the most important piece, right? Maybe it's the header, and maybe that's what you care about. Maybe it's the thing in the middle. Maybe it's the headline of your story. Maybe it's the lead image of the story. We don't know, and you need to instrument that. So to do that, we actually have a spec that's already available in all the browsers called user timing. And the API is very simple. You can annotate the performance timeline with your own metrics by calling a mark with start and end. And effectively, you set point on the timeline. You say, something's happening now, something's happening now. We also provide a measure interface where you can define a start and an end, and we'll get you back, like, how long did that take? So it's more of a convenience thing, because obviously if you have 2 timestamps, you can do this yourself. This is just a convenience wrapper. Now, in some older browsers, you don't have this. One really cool library is actually Pat Meenan's Polyfill. You can follow the link here at the bottom. It provides that same interface across all the browsers, even the ones that don't have this API. And further, it also adds capability to beacon this data back to popular analytics services. So for example, Google Analytics has a user timing capability which allows you to do this. So what Pat has done is he automatically connects those 2 pieces and says, if you mark events using this function, I will also beacon them back to Google Analytics or whatever vendor you're using. I think he also integrated with New Relic. So you combine those 2 things together and you get something like this. So once again, this is web page test. If you guys are not familiar with web page tests, I definitely recommend that you spend some time with it. O'Reilly, I believe, has a book in progress on web page tests, which is going to be great. But what Pat has done is he's actually integrated user timing directly into web page tests, where he will show you the last mark. So let's say you're annotating the timeline, like I'm rendering the pie chart or I'm rendering something else. He'll show you the marks in the timeline. So when you're looking at your resource loading, you'll actually see annotations saying like this happened here, this happened over there. And he also provides the actual marks and when they happened. Once again, it's a little hard to read, but these are marks that are specified by the application, right? So you can say, I'm rendering this particular template, I'm rendering this view, I'm rendering an image, whatever it is that is relevant to your application. This is where we need to go to deliver good user experiences. Page onload is a misleading metric for most applications today. So moving on, another API that's been available for a while, but I'm still finding lots of applications that could definitely benefit from it, is page visibility. So page visibility is actually best demonstrated with a demo. This is courtesy of the IE team here. So they have this little demo where you can see that when the tab is hidden, it just shows a red line, and when I switch to it, it's green. So if I just flip back a few times, you can see that it's detecting that the tab is visible or not. Is it in the background? Is the page being pre-rendered, for example? And this allows you to do smart things, or much smarter things in how you're actually interacting or what you're doing on the actual page. So the API for this is very simple. You subscribe to visibility change events, and visibility change can be hidden, visible, pre-render, or unloaded. So really what you care about is visible, right? Is the document currently visible? If it is, execute your logic. If it's hidden, maybe you want to stop animations. Maybe you want to stop polling for updates. This is a very frequent problem. You have some site that is trying to do real-time checks, and it just continues running in the background. Perhaps when the user switches away from the tab, you want to pause the video or do some other things. If you're running intensive animations, you probably want to stop those, right? So all of this stuff is very relevant, and actually deferring analytics beacons is an important gotcha. So modern browsers do a lot to try to optimize page loads. So they will even do things like pre-render a page in the background. Like think of a hidden tab in your browser. We will pre-render the page there, including executing JavaScript and all the rest. And we allow you to detect that that's happening via this API. So if you're firing your analytics beacons or making state modifications to to your page while it's in the background, that's probably a bad thing. You want to check if it's actually visible and then defer the beacons. So for example, Google Analytics automatically detects when the page is being pre-rendered by checking for visibility state, and it does not fire any beacons. So if we're pre-rendering and then you don't end up navigating to that page, there's no page view, right, as it should be. So you should think about this for your own analytics as well. I know that this has been a gotcha for some people. Moving on, another thing that's very common, speaking of beacons and all the rest, is blocking beacons. So this is a very popular pattern on the web today. You have a cart, or you have an ad, or you have something that you want to record that the user has clicked on that thing, right? Yeah, you want to provide analytics into, did the user click on that section, did they click on an ad? So typically today there's two ways to do this. One is you do a redirect, so you actually say, okay, before you go to the final destination, first go to this page, which will record the fact that you visited, and then you go to the destination. Alternatively, what you can do, and a lot of analytics vendors do this because they can't impose the redirect, is they will actually intercept the click. They will say, okay, stop propagating this click, stop propagating this event, send a synchronous XHR to their analytics service, wait until that returns, or timeout after a certain amount of time, and then they will yield control and allow the navigation to proceed. So obviously this takes a lot of time. We're talking hundreds of milliseconds for each click, right? So you click, you wait for the analytics to come back, and only then can you proceed. This is obviously an anti-pattern, and unfortunately this is more or less how the web is built today, because we need this for things like click attributions and advertising and all the rest. So to address this, we've had some capabilities in the browser. For example, aping. And this is something that Google Search actually rolled out last year. Aping is supported by Chrome and Safari on mobile. And what we're doing is when you're on the search results page on Google and you're accessing on your mobile phone, before we would do the redirect. Now we actually use aping. And ping, if you're not familiar with, allows you to specify URL that fires in parallel. So when you click, your browser starts navigating to the destination, and in parallel it fires just a request to another server that says, you told me to notify you when the user clicks, so here's a notification. This turns out to save about 200 to 400 milliseconds per click, which is a huge savings, right? And this is something that's really good. But the problem is it's kind of limited. Like if I wanted to beacon back JSON payload or some structured data, I can't really do that. I mean, I can encode it in the URL, but it starts to get really hairy at that point. And it's not supported by all browsers. So to address this, we've actually deployed Beacon API, which is supported by Firefox and Chrome today. And the idea here is the pattern that I showed you with I need to beacon back some data, but I want it to be asynchronous, is a fundamental block in the browser where you can say, send this data to this URL, here's a payload. This payload can be a JSON, it can be form encoded, it can be a binary blob if you care. As long as it's not too big. Like we don't want you to start clicking on a link and uploading a video, right? Like that's a bit too much. So we're restricting this to a fairly small payload. And this API returns immediately, which means that you click, it returns immediately, we can proceed, and then it's the responsibility of the user agent or the browser to ensure that that thing gets delivered. And we're actually putting a lot of effort to make sure that those beacons do get delivered, because for things like ad clicks and all the rest, obviously that matters a lot to people, right? Like if you start losing the fact that people are clicking on your links, that's a big deal. So this is a very important addition that will help a lot of different applications. And we actually have support for this in Google Analytics already. It's optional, as in you have to explicitly enable it in your config. And once you enable it, Google Analytics will check if your browser has support for Beacon, and if it does, it will use it. So if you're using things like Google Tag Manager and other things, this will just make things faster. But of course, you should apply this in your own code as well. So the fact that this is optional right now is more a sign of like this was introduced into Google Analytics while Beacon was being developed. So I'm hoping that in the future we'll automatically detect that you support Beacon and just use that by default. But for now, you just need to pass in an extra flag. And then if you use your own analytics, do look into using Beacon. You can very easily detect if it's available and then use that to avoid the extra delays. So this is really, really nice. So that's it in terms of the stuff that's already there. Perhaps some of those APIs like Beacon are not across all the browsers, but I think the support is coming. And now let's focus on some of the things that we've been thinking about in terms of like other use cases and other problems that we see in the wild. So one problem that you can't currently address is more of an operations problem on the web today. And in particular, it's the fact that if the user actually fails to make it to your site, you have no idea, right? Let's say I'm on a shaky connection and I'm trying to access your site, and maybe the DNS server is down, so can't access your site. Maybe the handshake fails, the TCP handshake fails, or maybe the certificate is misconfigured or something else happens. In all those cases, that request never hits your web server, right? Not only that, but even if it hits your web server, you may not record it if you use client-side analytics. So all those cases are just completely lost. We're in the dark, right, in terms of like how many users are failing to reach my site. Maybe there's an entire region of the world where my site isn't accessible because of, I don't know, network misconfiguration. So the very large sites can, of course, build some infrastructure to address this, but we want to make it easier. So the idea here is that we're going to be introducing something like an error logging API where the site itself, so let's say I send a request to fetch your awesome page or your awesome service. When you respond to us, you can actually provide a report URI that says, for error reports, please send them to this destination, right? So I have this other third-party service. And by the way, if this is example.com, your monitoring server should be something else, right? Because if I can't access example.com and I try to send a report to example.com, that's obviously not going to work. But once you've registered that with us, the browser will then, in the background, once it's connected, send this data back to you and say, hey, the user tried to connect to your site on Friday, November something at this time, and the connection failed because of this reason. You may want to look into that, which is kind of nice, right? And now you can aggregate that data, analyze it, and figure out operationally, is that a problem? Maybe, after all, maybe it's just a shaky connection that the user had, so it's not my fault. But nonetheless, this would be a very important addition. So at this point in time, we're still iterating on the actual format of the spec or the API as to how this is going to look. In Chrome, we've actually just recently shipped a feature called domain reliability, which is exactly what I'm describing, but a lot more. And we developed it to monitor our Google properties. And now we're trying to apply some of the things that we learned while we were developing it and make it a public API that is accessible by any site. So if you're in operations, this will definitely be relevant for you. So I encourage you to check out both the domain reliability doc and the actual discussion on the mailing list if you have use cases or feedback for how it should look. So that's the case of not being able to get to the site. The next step is actually server timing API. So the use case here is, sure, we've managed to do the DNS, the TCP, and the TLS handshake, but then you have an HTTP request, which is taking a really long time, right? And today, if you look at your network waterfall, sometimes you see those things, and it's like, oh, this thing took 5 seconds. Why did it take 5 seconds, right? And at that point, you're like, okay, well, I need to go find the appropriate log file and the appropriate application server and figure out what the hell's going on. And that's good if you can actually find that log file. But what if the problem is the fact that you have multiple servers, like proxy servers and a CDN in between? And what if it's the CDN that's actually injecting some of that lag for some particular reason? So this is basically just a very black box, or a black box that's very opaque and hard to debug. So we figured we can actually address this in kind of in a simple way through 2 things. One is providing just a standardized HTTP response header where your application or your proxy servers in between can actually add very limited but useful timing data for things like, so basically they can pass arbitrary key value pairs, right, which has a name, a duration, and a description. So this is that composes a metric. So you could say, for whatever reason, the database took 53 milliseconds, my custom view something application took 47 milliseconds to generate this, and perhaps my CDN added a note saying that this was served from a data center in Atlanta, right? These kinds of things can be added by multiple servers along the way, such that by the time we get the data back, we can actually surface it once this format is defined in the browser. So for example, we're still iterating on what the right API is, but if you think about it, this is relevant to each and every request. So for each request in the resource timing and navigation timing, you would have a new object, something like server metrics, which would just contain a list of metrics that are initialized from the data that I showed you before. So for example, for this guy right here, the name would be app, the duration is 47 milliseconds, and the description is custom view. So it sounds very simple. Yes, you can sort of get at this data today if you have custom instrumentation logging on your servers, but the combination of a standard header and an API allows us to surface this data in DevTools. So now you can actually hover over that really long request and get some insight into where time was spent, and also allows analytics to gather this data automatically. So analytics vendor to surface it for you. So we're still trying to figure out the exact use cases, making sure that we've covered all the necessary use cases and iterating API proposals. But this seems like a fairly simple, fairly relevant thing to a lot of people. So I'm hoping that we'll see this soon. So we fetched the resource. Let's say it didn't take that long. But despite all of that, right, even if it was successful and you've optimized your backends, this thing, fetches can still take a long time. So on even Wi-Fi networks, we're talking tens to hundreds of milliseconds, and on slower mobile networks, you're in thousands of milliseconds oftentimes. So here's some fun data that I pulled out of my own browser. So this is after about 2 days of me browsing in my Chrome browser on a really fast Wi-Fi network. So this is our corporate Wi-Fi network at Google. And I just looked up some histogram data within Chrome for like how long does each step take for me, right? And once I add it all up for like a typical connection, you have DNS, TCP, TLS, HTTP request and response. The average time to set up, or the median time to set up the request, was about 200 milliseconds. If you try to do the same math on a 4G network, which is basically your mobile phone, you're looking at half a second. And on slower networks, you're looking at a second. And this is just to fetch like one file, right? And of course, as we all know, a page is much more than one file today. It's like hundreds of files and megabytes of data. So all of this time adds up. And all browsers have gone to great lengths to try and hide this latency from us. We do a lot of tricks under the hood to abstract this by doing things like, well, I'm not sure if you're going to really fetch resources from that domain, but just in case, I'm going to start pre-resolving the DNS name because I don't want to block on it later. I'll go even further, and I think I know you're going to connect to this host, so I'm going to start connecting now, such that by the time you send the request, I already have a TCP connection. And same thing for TLS. So we use a variety of these techniques under the hood, and if you guys haven't looked at it, at least in Chrome, you can get a fairly low-level look at how all of the stuff is happening. So if you look in Chrome DNS, you will see all the DNS host names, how frequently we've connected to them, and some debugging data. Histograms contains pages and pages and pages of histograms of how long different sequences of events took. And Chrome Predictors is a fun one where you can actually see as you're typing in the omnibar at the top or the URL bar at the top, we're trying to predict where you're going to head. And if we have a good prediction, we will start pre-rendering that page. And you can actually see what those stats are for your particular browsing history. So I know that for me, if I type in A, there's about 50% chance I'm going to Amazon. If I type in AM, there's a 99% chance I'm going to Amazon. So at that point, Chrome starts fetching resources from that page, which is kind of like a fun optimization. And further, we have other tricks for things like when we process the HTML document, there's lots of scripts, lots of blocking scripts on most pages today. So we have things like preload scanners, which even though we have to block on the script, we have this kind of second parser that peeks ahead in the document and starts finding other resources. So things like images, scripts, and style sheets, and initiates those fetches early. And this is all kind of automated magic in the browser that we have to do to make your experience faster. But the problem is there's no API for most of these in the browser today. We have things like rel pre-render, which is great because it allows us to hint the browser that I think the user is heading there next. But there's still kind of some missing components. And in particular, there's one that we're iterating on right now, which is rel preload. So the idea with preload is this is a declarative fetch. The only thing that it does is fetch the file. And you can specify, so first you specify preload, you specify what file or what resource you want to fetch, and then you have to specify its type. Unfortunately, we can't rely on extensions because lots of times URLs don't even have extensions, but you need to communicate to the browser, like, what is this thing that I'm fetching? Because browsers actually fetch different resources with different priorities, they append different HTTP headers, and we need to initialize that somehow. So you're saying, look, please start fetching this font as soon as possible, and also start fetching this CSS. And this is a style sheet. And yes, I want to apply this media query. But the important thing here is, in particular for the style sheet, this style sheet won't be applied to the document. So if you specify rel style sheet, once that thing is downloaded, it is injected into the page, and the styles that you specified will affect how the page will look. This will only fetch the file, and it relies on you to then later inject it into the page. But hopefully by that point, the file is already in cache, and it's very quick. So this is a really kind of, it seems very simple, but it's a fundamental block that allows us to build lots of other very clever things. Like, you can start fetching multiple files, and you can then wait for all of them to complete, and you can basically build very smart preloaders for this sort of thing. We have some of those capabilities today, but they're all based on XHR, or XML HTTP request, and they create their own sorts of problems. Because this is declarative, this is also discoverable by the preload parser, which means that we can initiate these fetches much, much sooner. So this is great, but sometimes there's another case, which is we don't actually know the URL we're going to fetch. And here's a concrete example. If you guys have ever used or use Google Fonts, Google Fonts does a clever trick. First, you declare that you want to use a particular font family, right, and particular weights and all the rest. So here I'm just saying Open Sans. And that style sheet actually returns a dynamic, different response for each user agent, where we look at like, okay, well, this is Opera coming, and Opera understands the following font formats, or it supports the following font formats. It supports the following font features like Unicode range and all the rest. So we will return this sort of markup. Whereas if an old IE7 user comes in, we'll return a different type of markup. So the problem here is that the URLs for the actual font files themselves, you don't know up front because those are different each time. But you do know that you're going to be fetching for sure content from this domain, themes.googleusercontent.com, regardless, right? So this is kind of hidden one layer underneath. And we can address this by pre-connect. This is something that is supported by every browser today. It's just not exposed to you as a developer. So the idea here is you just say, look, I know I will fetch things from this domain, from this origin. I'm just not sure what the URL is. So start pre-connecting now, and you can do three things. You can do the DNS lookup, you can start initiating the TCP connection, and if it's over HTTPS, then please also do the TLS handshake negotiation. So if you're doing all three of those, that's 3, 4, sometimes even more round trips that you would have to block on otherwise. So this allows us to just optimize for those cases. So very simple, but very effective. And in fact, most browsers today support something that's called DNS prefetch, which is basically just one step of that sequence. And we're just going further and saying, like, look, there's no case where you would ever want to resolve a name without connecting to it. At least no legitimate use case that I can think of. So in effect, we're actually talking about, could we, for the sites that use DNS prefetch today, could we just upgrade them into pre-connect? Because really, that's what they want anyway. So we'll see. Another thing that's important, as we've been circulating this proposal, is a lot of CDNs and server vendors, FEO products, front-end optimization products, came in and said, look, we're actually doing a lot of these tricks already, but we have to do them in a very nasty way. Things like a request comes in, we flush a fake header of the HTML document where we initiate XHR requests while we wait for your server to respond. It's really nasty stuff. So it'd be really nice if we didn't have to modify the HTML response or like create fake documents on the site's behalf. So because of that, having support for just initiating fetches via the HTTP link header would be very powerful, because we can leave the HTML page itself intact without modification, which is actually important for security as well. And we can just annotate these things via HTTP headers. So if you say, please pre-connect here, it's equivalent to you specifying that same piece of data in HTML markup. So that's important. And of course, this would work for pre-connect and preload as well. So a very simple tool for CDNs and others to make use of this as well. And then finally, we have speculative fetching. So everything I've talked about up to this point is I know I will need this resource, start fetching it early, or I know I will be fetching resources from this origin, so start pre-connecting to it. Finally, there's cases like, look, the user is reading page 1 of my article, and I have page 2. I know that's where they're heading, right? Or based on some stats on my application, I know that this particular user always goes into the news section and then always clicks on the, I don't know, on the football section, right? Like that's that sequence for that particular user. If you know that information, you can start prefetching that data early, right? And by prefetching it, you can deliver a much better experience. So you can modify, you can put a modifier on the preload to say, next is just a keyword that is a hint that says, this will be used for the next navigation. And this is important for the user agent because it allows us to schedule that fetch in a way that doesn't compete with the original page. Right? So if we're preloading a lot of resources, usually we're actually maxing out the bandwidth, or if we're maxing out bandwidth, we can defer this fetch to say, I will do this at like low priority after everything else on the page is done, such that it does not interfere with the current page. And then finally, this inert keyword allows us to say things like, express things like, do you want this content to be pre-rendered? So today we have rel pre-render, but we also have prefetch. And the difference there is pre-render will fetch the document and start parsing the HTML and executing JavaScript, whereas prefetch will only fetch the HTML document and not do anything with it. So inert just says like, I want you to fetch that thing and just don't do anything with it. Like, don't start decoding the image. Don't start parsing the JavaScript. Don't parse the CSS. Whereas if you omit it, it allows the user agent to do some of that work up front. So for example, if you preload an image, we can go ahead, fetch the image, and decode it, such that by the time you inject it into the page, we can immediately put it on the screen without wasting any other CPU cycles. So a combination of all of these things allows us to be very flexible in how and when we load content, which is quite nice. And then finally, I've talked a lot about network. That's what I tend to do. But it's very important that we optimize the actual experience of the application once it's rendered as well, right? The way I think about it is, first, you want to deliver the 1 FPS experience, which is you want to load every page in 1,000 milliseconds. That's your first frame. And that first frame should be within a second. Once you deliver that first frame, you should be rendering the rest of the application for the remainder of the time at 60 frames per second. And we've built some really great instrumentation in all of the different browsers to allow you to peek under the hood of the rendering pipeline to see things like, what is my frame rate? And how long did the frame take? And was it the layout that was bottlenecked? Was it the CSS styling? Was I manipulating DOM too much? All this stuff is great. But if you think about it, we have the same problem that we had before navigation and resource timing, which is I can debug it on my device, but I don't know how it runs on my actual clients or my users' devices, because there's a variety of them. So for that, there's actually a proposal from the Chrome team, which is now an API spec that we're iterating on, which is called Frame Timing API. And specifically, it will expose, or the current proposal is that it will expose 2 types of events, renderer events and compositor events. And if you're not familiar with that language, there's a really good explainer doc that we have in our repo that I will link to on the next slide, so do check that out. But the idea here is that for each render event, we will tell you the frame number, when it was started, how long it took. And each renderer, which is kind of the main thread event, can in turn trigger multiple composite events, which typically run on a separate thread, although it depends on your architecture. And once you have that data, it is very low-level rendering data. You can actually construct things like an FPS counter directly in JavaScript, or you can instrument particular animation at a particular point in time and say, I want to capture how this works, like how many frames am I getting, or perhaps you want to instrument your scrolling at a particular point and just capture that point in time. You can then beacon that data back to your servers and then figure out that, hey, on this particular device, I'm having some FPS problems, right? So once again, ROM for animations is really cool. And here's a kind of a trivial example. So let's say we have a menu button and we register a click event, and that menu button triggers some animations on the screen, right? Pretty simple. We have a buffer which accumulates rendering events. You can clear it when the click happens. You can perhaps adding the expanded property triggers the CSS animation. Once it's done, on the transition end, you would then check the buffer for the render events and the compositor events and process it, beacon your analytics to the server if it's something abnormal, and then move on. So this is obviously not the actual API. There's a very good explainer that you can read at the bottom here. So I encourage you to check it out if you're interested in rendering performance. And of course, everybody should be. So we're iterating on the spec right now. We actually have an early prototype in Chrome. It's not under any flag right now. It's literally just a patch that we have that does most of these things, but we have not yet landed it. But I'm hoping that within the next month or so, we'll be able to standardize the spec, or at least agree on the general surface area of the spec, at which point we can actually make it available in Chrome for Canary builds and other things. So far, we've had really good feedback from Safari, Firefox, and IE teams, so they're all very much interested in this. So with that, we actually come to the end of our whirlwind tour. And as you can see, there's a lot of stuff here. There's a lot of APIs that are currently available that I think a lot of applications need to make better use of. And of course, we have new stuff that's coming that I'm hoping that will actually enable and you'll see in 2015 in the browser. And then finally, because this is the most important point, especially for the second half, is we're looking for your feedback, for use cases. And out of the things that I've described, are they relevant? Do they sound useful? Do you have better proposals? Maybe there's a particular problem that we're not solving. Please do go to the public webperf mailing list, or go on Twitter and send a message to me to tell us what that is, so we can make it available. And with that, thank you, and the slides are at the top there. And I'm not sure if we have much time for questions, but I'm happy to take questions.
Actually, I have two questions. The first one is, how can I know if is there any event when I use rel preload or rel prefetch?
Is there any event when you use rel preload or rel prefetch? So just like any other element, you can register a load event on it. So the load event would fire when the request has finished.
Okay. And the other one is, could you explain us what is the difference between attributes like defer and async?
Right.
With these new attributes?
Yes, so the defer and async, that is probably worth its own talk on its own. So defer was introduced by the IE team, and I believe IE7. It came before async, and it's not terribly well supported by other. So think of async as a replacement for defer. The only time you should be using defer is if you need to target old IE browsers, so IE7 and I believe IE8. When you see scripts today that say async and defer, the only reason you add defer is to cover those old cases, to cover old IE cases. So that aside, the idea with async is today if you put a script tag, it is blocking in the sense that before the document parser can proceed, we need to go fetch that resource, fetch it, execute it, and then we can move on. With async, when we see the keyword, it's actually kind of like a card or a note that says this thing does not modify the DOM, so you don't have to wait and block on that thing. You can continue parsing, and this accelerates the page load significantly because it allows us to continue parsing the document and get something visible to the user much quicker. But the trick there is your code that runs needs to be aware that it's running in async fashion, so you can't assume that it will run at a particular point in the document. It will execute at some point when the download is done.
Hello. You have talked about the Visibility API, and I'm working on some project inside Chrome, and I now see related to Canvas, and I see how when the page is hidden, the frame rate low. So what about an API for locking the resources? In some way, I want to keep myself hidden, but I want to retain the CPU and to retain the FPS high. How about this kind of APIs? You didn't comment anything.
So that's a good question. There's no such thing. So you're right. Chrome and other browsers will do throttling based on the state of the tab, right? So if you think about it, we have some users have, believe it or not, hundreds of tabs open, right? And because of that, we need to aggressively throttle and give resources to the tab that's in the foreground. And we do that by, actually, every browser does this, by, for example, in timers, if you're JavaScript timers, they'll fire less frequently, right? So the time gets dilated, basically, and frame RAF timers may not fire, and other things. There's no API that I'm aware of that will allow you to lock resources for that particular reason of, if every tab claims that it needs 100% of the CPU, that doesn't work, does it? So we need to kind of retain the right to throttle you. But we will give you as much resources as we can when you're active. Maybe there's more use cases there, maybe there's some constraints, so I'm happy to chat afterwards.
I was asking because I'm working on Firefox OS, and in Firefox OS we have this problem of keeping the CPU, and we implement a custom API called CPU lock. Mm-hmm. And when you call, but you need certificates permission, when you call CPU lock, you retain the CPU.
Right.
In order to avoid this kind of problems of timeouts and low FPS and so on.
Yeah, so perhaps this is an API that is more API-like, right? So you would need to request much more permissions for things like, I want to store a lot of data on your device, and I want to have full access to your CPU. So maybe that's where it would make more sense. Yeah.
Thank you.
Yep. All right, thank you guys.